Well, hi there, kiddos. We are going to talk today about some things called functions and relations. So you're finally going to get some definitions for a word you've been hearing for the last several days. I've been saying functions for the last several days. Now you're actually going to get a definition. So there are two we're going to do first. There is a relation and a function. A relation is nothing more than a set of ordered pairs. Whoops. A function is a relation where each x pairs with only one y. The thing I want you to put in parentheses, because the important way, the thing about this, the thing I really want you to remember is that x values do not repeat in a function. That's the thing that I really want you to get from that. The definition is each x pairs with only exactly one y, but the thing that I really want you to remember is that x values do not repeat. If x values repeat, you no longer have a function, and we'll talk about that as we go through the lesson. So your very first problem, you were given an actual relation. You need to fill this in to the little box that's empty on your notes where it says problem number 1. So we're going to fill that in. You're going to write down those ordered pairs. And then before we answer these questions over here about is it a function, domain, and range, we're going to go ahead and fill it into the table. And so I'm going to put these in my table, x values here and y values here. A table is just another way to represent what is happening here in this list of numbers. I find that the table is sometimes easier to look at because it separates all the x's and then all the y's, so I can look at them individually and they're not all jammed together, but it's just how you see things. So in my table, I'm going to put my first ordered pair. I have 2, 5, then the next one is 3, -2, and then 4, 3, 5, 1, and then 6, 3. And so now I have this lovely little table, and I have listed out all my x's and all my y's, which makes getting the domain, range, and all of that very simple, okay, because it's all right there in front of me. First of all, the first question says, is it a function? Well, to tell if it's a function, I'm going to look at the x values. Are any of the x values the same? I've got 2, 3, 4, 5, 6. Those are all different numbers. Therefore, this is a function because none of my x values repeated. To write the domain, I'm just going to list them out. Least to greatest, 2, 3, 4, 5, and 6. Then I'm going to write my range, but be careful. You want your range to go in order from least to greatest, and so you can't just start at the top and write them down. You got to pick them out. The smallest one is -2. The next one is a 1. Then you have a 3, and there are 2 of them, but remember when we write range, we only write it once, and then there's a 5. And so it's okay that our range is shorter than our domain. When you start having a problem is when your domain is shorter than your range, because that is a hint to you that what you have is not a function. Now, there are multiple ways to represent a function or a relation. There are several ways to do it. One way is to write it as a list of ordered pairs, which is what they gave you as the problem. The second way is to put it in a table, which happens to be my favorite way because I feel like it's very easy to see things from there. The next way is to do it as a graph or as a mapping. So we're going to do the graph first. Well, to do a graph, I'm just going to plot these points on the graph. So I have 2, 5, then I have 3, -2, and then I have 4, 3, 5, 1, and 6, 3. I am not going to connect these dots. It doesn't say anywhere to connect them. I'm just going to graph it. Okay, so I'm going to leave it as a discrete graph. That's what it's going to look like. And you can see none of the x values line up because you don't have any points that are one right above the other. If x values line up, so if x values repeat, you're going to have points that line up because this number down here, this x number, will be the same. Now, the last way that you could see a relation or a function represented is this thing called a mapping. And it is exactly what it sounds like. It is a map. It shows which x values map onto which y values by drawing these pretty little arrows. And so here's how it works. You draw these ovals. You put your x's in order from least to greatest in the oval on the left. You put your y values in order from least to greatest on the right. And you do it just like you would do your domain and range. So if you write your domain and range first, this becomes very easy. Your domain goes in the x, your range goes in the y, because we do not write repeated numbers in a mapping, just like we don't write them when we write our domain and range. So my domain was 2, 3, 4, 5, 6, and your range happened to be -2, 1, 3, 5. So it helps if you find the domain and range first, then go make your mapping. So now here's how the map works. I'm going to draw arrows from these x values to show which of these y values they match up with. So the 2 goes with the 5, so the 2 maps to the 5. My 3 goes with the -2. My 4 goes with the 3. My 5 goes with the 1. And my 6 goes with the 3. So I have 2 arrows going to the same place, which is totally okay. As long as they are going to the same place, it's fine. What you do not want is 2 arrows leaving from the same place. That means you don't have a function. So that is the 4 ways we see a relation or a function represented: ordered pairs, table, graph, mapping. So let's practice another one. So here is problem number 2. They have given you the ordered pairs on your paper. We're going to go through this, write the domain and range, fill in all the stuff, and then determine if it's a function or not. Like I said before, I like to do the table first because I find that it is very easy to see the domain and range once I'm in the table. So my first problem is 0, -1. Then I have 0, 1. Then I have 2, 2, 3, 4, and 4, 0. So now, from here, I have them all listed out in a nice, pretty little ordered pair. And I've written it in a table. And so now I can look at my table, and I can pull out my domain and my range. So I'm going to list out my domain, least to greatest. Don't list anything that repeats. So I have a 0. Since I have 2 of them, that's cool, but I'm not going to write the second one. Then I have a 2, a 3, and a 4. Then my y values I'm going to list in least to greatest form. The smallest one was -1, then a 0. Even though it's down here, it's still the next smallest one. Then 1, 2, and 4. And you should notice that your domain is now shorter than your range. That should be a signal to you that there is a problem. And the problem is that this is not going to be a function. The reason it's not a function is because you have 2 zeros listed in the x column. So you have x values that repeat. And I'll show you what that looks like on the graph. So when we graph it, we're going to plot those ordered pairs. I have 0, -1, and I have 0, +1. And then I have 2, 2, 3, 4, and 4, 0. If you will notice, these 2 points line up with each other, and the reason they line up with each other is because the x values repeated. Since x values repeated, I don't have a function. So when I have 2 points that line up with each other vertically, up and down this way, I don't have a function, because that means x values are the same. This x value is the same as that x value. So that's another way to tell. So now we'll do our mapping. Domain goes here, range goes here. So I have 0, 2, 3, 4. Then over here I have -1, 0, 1, 2, and 4. And then I map and draw my arrows. So I have a 0 that goes with -1. I also have 0 that goes with +1. Then I have 2 goes with 2, 3 goes with 4, and 4 goes with 0. Here's where there's a problem. This 0 has 2 arrows that leave from it. Anytime that happens, 2 arrows leaving from the same number means I don't have a function, because that means that x value got used twice. This x value is paired with 2 y's instead of just 1. So is this a function? No, it's not a function, because the x value 0 repeated. It was there twice. So anytime you have an x value that repeats, you do not have a function. And in this case, the x value that repeated was the number 0. So that is how we do graphs when we do the mapping. So now we're going to learn this thing called the vertical line test. And the vertical line test is really very simple, but for some reason, because it's the first time that you have seen it, you're going to look at it, and you're probably going to have to replay this part of the video a couple times. It's okay. The vertical line test is really easy. The vertical line test basically says that if a vertical line passes through a graph more than once, then the graph is not the graph of a function. The reason why the vertical line test is important is because sometimes all you're given is a picture. You are not given a table or the domain in the range or anything like that. You were just given a picture. So you're given the graph and you have to determine if it's a function or not. And in order to determine if it's a function or not, the best way to do that is use the vertical line test. And to pass the vertical line test, a vertical line test can only touch or pass through a graph one point at a time. If it ever passes through more than 1 point at a time, then it does not work and what you have is not a function. So let's do a couple of examples. So we're going to use the vertical line test to determine if either of these is a function. If it is not, we're going to list two ordered pairs that show the same x value with two different y values. So we're going to show y, and then we're going to write the domain and range just because we want practice on domain and range. So I'm going to make a line here. Really like this red one. Okay, so I'm going to make myself, oh, that's kind of fat. I don't want that fat of a line. So hang on just a second and I will get me a line that will. Okay, so now I have myself a line, and it's a vertical line. It goes straight up and down, and I'm going to use this vertical line to test to see if this is a function. You can use a pencil, you can use a piece of paper, the edge of a sheet of paper, anything that goes straight up and down. And what I'm going to do is I'm going to take this vertical line and I'm going to move it across my graph. And if you will see, right here, as soon as I started at this point on the graph, this line passes through my graph that is drawn twice. It passes through 2 points at the same time. If I move it here all the way over and I keep going, everywhere through here, this line passes through that graph in 2 different points, here and here. It's still at 2 different points. It still passes through 2 points at the same time. It never passes through only 1 point until it gets all the way down here to the end. So because this vertical line at any point on this curve went through that curve in more than 2 points at the same time, then what I have is not a function. And so what I'm going to say is that this is not a function. Okay? It is not a function because this vertical line hits it in 2 different places at the same time. Now the next thing we have to do is list 2 ordered pairs that show one x value with 2 different y values. And so we're going to move that vertical line out of the way, and we're going to do that very thing. So we're going to mark 2 different points. I'm going to say, let's do this point and this point. And so if you look, this point is at -4, +2, and this point is at -4, -2. And so you will notice now I have a repeating x value with 2 different y values. So I do not meet my definition where every x is paired with only one y. This x is paired with 2 y's. It's paired with 2 and -2. If I were going to write the domain and range, let's go ahead and take care of that. The domain is going to be the left and the right. Well, these arrows extend to the left forever, so it becomes -infinity. But it stops right here at 0 and doesn't continue on. My range, on the other hand, because of the arrows, goes from -infinity to +infinity because those arrows are going to go up and down forever. So let's do the next one. Let's take our vertical line and let's have it pass through this graph. So I'm just going to move it back and forth across this graph, and I want you to look as I do. Is there ever a place where this blue line passes through that graph, that V that is drawn on this paper, more than 1 point at a time? I don't see a place where it ever goes through more than 1 point at a time. Here it passes through it in 1 point right here. If I move it over here, it's still just at 1 point. Right here in the middle, it's still just at 1 point. So this line never passes through this in more than 1 point, which means this is going to be a function. So when I do this one, I get to say, yes, this is a function because that vertical line never passed through it in more than 1 point at a time. It never hit more than 1 point at a time. So I don't have to list ordered pairs for this one, but they do want the domain and range, so we're going to do that. Domain, left forever, right forever, so negative infinity to positive infinity. My range, on the other hand, has a minimum point right here at 0, so it goes from 0 to positive infinity because those arrows also extend in an upward direction. So a couple more sets of examples. These are discrete graphs. We're still going to do the same thing. We're going to find out whether or not they are functions, just like we did with these continuous graphs. So we're going to take our line over here to the next page, and we're going to do the same thing. I'm going to take this and I'm going to see, oh, if you look, it's touching 1 point, 1 point, 1 point. Only 1, 1, 1, 1. Never does this vertical line hit more than one of those points at a time. So that discrete graph, that is actually going to be, this one is a function because it never passed through more than once. I'm not going to list the domain and range. Feel free to do so if that's just really what your heart desires, but you do not have to. So for the next graph, if I line up my vertical line on this graph right here, it hits 2 points at the same time. If I put it over here, it also hits 2 points at the same time. Same here. There are 3 different places along this discrete graph that this vertical line hits more than 1 point at a time, which makes this not a function. And so I get to say that this one is no, it is not a function. That is the vertical line test. That is how we use it. And so now you have your vertical line test, you have your domain. Oh, we're going to list 2 points. Let's just go ahead and do this point and this point. Well, the ordered pair for this point is 2, 2. The ordered pair for this point is going to be 2, negative 2. And so you have the same x value paired with 2 different y's, which is why it's not a function. It's why that vertical line went through 2 different points. You can list the domain and range if your heart so desires. If not, we will practice this tomorrow. Please make sure that you have your notes with you and that you work on this while the sub is here with you in class. I will see you guys not until next Thursday. This is your last video until then, and so you have no video over the weekend. Have a nice long weekend. I will see you then.